Welcome, everyone. My name is Jesus Centeno, and I'm the Chief of Staff to the Office of the CTO at TIBCO. And today I am joined by my colleague, Miguel Torres, Director for Americas at the Office of the CTO as well. Together, we're going to talk about analytics at the edge and how to leverage Project AIR from TIBCO Labs for such purpose. Thank you for your time this morning. So before we get started, a quick reminder on our confidentiality policy and forward-looking disclaimer. So I mentioned Project AIR, which is part of a larger innovation program at TIBCO called TIBCO Labs. Under the TIBCO Labs umbrella, there are other projects that focus on different areas of technology and innovation, such as blockchain, augmented reality, process mining, natural language processing, AI, knowledge graph, and many others. Today, we're going to focus on Project AIR and analytics at the edge. So, what is Project AIR? Project AIR is a platform that allows you to register and interact with IoT devices, build data pipelines at the edge and at the cloud to process your IoT data in any way you need. It allows you to keep ownership of your IoT data, analyze the data at the edge and in the cloud, and store it wherever you need it. Project AIR is extremely flexible, so you can deploy it in any cloud ecosystem of your preference, and it is highly extensible, so you can easily integrate it with other platforms in your ecosystem as well. So when we talk about edge analytics, we are implicitly talking about edge computing. What is edge computing anyways? Edge computing is distributed computing that brings computation and storage near to the request and the device. But why is it important? Without computing capabilities at the edge, you have to transfer all the IoT data to the cloud, process it there, and communicate back to the edge with any relevant insights to take action at that point in time. This approach tends to be expensive and slow at times. So with edge processing capabilities, the IoT data can be processed at the edge, and any identified threats, anomalies, and opportunities for processing the IoT data can be translated into immediate action. Data is transferred to the cloud after the action has taken place and only as needed. Edge computing reduces latency and operational cost. Now, when we talk about Project AIR, let's take a look at what Project AIR actually looks like. Project AIR is based on a distributed architecture with components running at the edge, typically in the IoT gateway, and other components running in the cloud, such as the console UI. Through Project AIR's console, you can map your IoT devices, build data pipelines, capture all the required business rules and alerts on how to react upon certain events, and orchestrate the deployment of machine learning and computer vision inferencing models. Furthermore, Project AIR allows you to send commands back to IoT devices in order to respond to specific events. At its core, Project AIR leverages an open source framework from the Linux Foundation called EdgeX Foundry, which I'm guessing many of you are familiar with it already. There are many new features in Project AIR that we are very excited to talk about today. So let's take a quick look. First one, pipelines at the edge and or at the cloud. As I mentioned a moment ago, Project AIR allows you to create data pipelines to process your data at the edge and at the cloud. The data pipelines are powered by Project Flogo, and the console allows you to configure and define your data source and target, as well as leverage from a list of options to manipulate the data as needed. You need to dynamically deploy a new machine learning model at the edge for inferencing purposes or leverage existing or new REST API calls. Project AIR will get it done. The second aspect is computer vision. So Project AIR's capabilities are extremely horizontal. They can be leveraged in any industry for a wide range of use cases, such as predictive maintenance, metering, asset tracking, telemetry, and many more. Over the last few months, we have now added computer vision as one of the hottest use cases within edge analytics. The main reason why computer vision has become so popular is because of the enormous number of use cases that it can address. From face recognition to body movement analysis to object identification, Project AIR can easily leverage the output of computer vision inference models to do analytics on video stream-based data. those insights actionable. For example, computer vision models can easily provide intel in terms of social dynamics, security measures, compliance, and even social distancing. Now, the third and fourth area are based on our recent collaborations with other big players in the space, such as Intel and Canonical. These are great examples of Project AIR's extensibility aspect. Project AIR can easily incorporate a wide range of video analytic frameworks, such as Intel's framework called Video Analytics Service, also known as VAS, that is based on an open source project called OpenVINO. Also, Project AIR can be packaged in a number of different ways. Through our collaboration with Canonical, Project AIR components can be now packaged using Snap packing technology from Canonical to speed up its deployment in Linux operation systems such as Ubuntu. So with that, let me pass now the ball to my colleague Miguel, who will walk us through the demo portion of today's presentation. Miguel, please take it away.
Thank you, Jesus. Share my screen. So taking over and talking about the actual distributed architecture, we're going to show today a demo by our one of our lead architects, Marcelo Gallardo. That one shows how you can deploy machine learning models at the edge, in this case to a camera, and actually use Project AIR to create some pipelines that actually feeds that information and bring this all the way to the cloud. Super powerful. So he's going to show how the actual video shows how to recognize whether you have a mask on or off, and have a pipeline that is created using our our Project AIR interface to send that data all the way up to the cloud.
In this demonstration, we're going to show how to use video analytics with Project AIR. In this particular scenario, we have a camera capturing video and the frames being evaluated by a mask recognition model that has been deployed to the camera itself. The results of the model and some of the image when a particular event is identified are published for further processing by Project AIR. More specifically, we have configured the video analytics pipeline to send images when it detects a person wearing a mask. It could have been configured the other way, but for demo purposes, we selected the mask wearing case. Let's look at it. So here in the demo, we can see that I have a camera in front of me, and we have a model that's running and is detecting if I am wearing a mask or not. If I remove the mask, the model detects that I don't have the mask. If I put the mask back, the model detects that I have the mask on. Let's try a few more times. Now, this time, the model, after it executes evaluates the image, it sends the results back to Project AIR, and I will show you that next. For this part of the demo, we go back to Project AIR's user interface, which presents a summary of the different locations or grouping of devices managed by the framework. These groupings represent a digital twin of the real devices at the edge. Now that the events from the video analytics pipeline were sent and captured by Edge's framework, we will show a simple flow that has been configured to further process the events generated by the video analytics pipeline. In this simple demo, we simply route those events to the cloud where the events are stored in AIR's data store. Let's see how to do it. Let's click the pipeline. This will take us to the pipeline editor. Here we can see a list of all the different flows that have previously been created. We have here one that's called basic file. If I click there, we can also see that the status is deployed. So this is the one I used to capture the video analytics events and save it to AIR's data store. So how we did it is we just configure a data source activity that's a subscriber activity, subscribing to the events coming from Edgex. And then we created a publisher. Activity that receives the events from the data source and then just sends to the cloud, where we have another process, the AIR process, that is storing those events into a graph database for visualization. Now that we have configured a flow to handle the events coming from the devices, let's go and let's review the details of the devices. So let's go back to the grouping and let's click on the view details. This will take us to a page where it will give us a list of all devices managed by this group. In this case, we can just see a camera that's called the DVI OGD camera. And here it gives us an overview of the camera. And also here we have two tabs that has the data that has been received from that camera. One is the snapshots received from that camera, and the other one is the infer results from the model. So if we click on the Infer tab, we can see all the different the results that the model generated. So we can see here all this. We can see that we received that the model detected a person with a mask, and also we have some with no mask. We can see it's interleaved when I was wearing the mask and when he was not wearing the mask. And also if I go to the snapshot, I can see the last snapshot that was received from the camera, and here I can see the image that was evaluated with a mask, and here I have also the result. This concludes the demonstration. If you guys have any questions, please feel free to contact us. Thank you.
So yeah, just to recap, we've seen a model deployed at the edge right at the video, which actually reduces the latency and makes the performance to be as good as it gets. Also, we are deploying pipelines using Project Air straight at the edge as well, really close to the devices, and also allowing through channels and these pipelines to send the data all the way back up to whatever you want. Really, you can leave it at the edge, or you can send it to the cloud, as in this case. There's much more that you can do. So yeah, thank you so much, and over to you, Jesus.
Excellent, Miguel. Thank you so much. So let me share my screen again. And I have a couple of announcements before we discuss any questions on Project Air. So the first announcement, TIBCO Labs is having its yearly open source day event in a couple of weeks. We're very excited because this year, for the first time ever, we're going to have two events. One for EMEA and APJ on May 18, and one for Americas on May 20th. So make sure to sign up today. The links are on the screen, and you can see the agenda, the full agenda, once you go to the site. We will have awesome speakers from companies like AWS, Microsoft, Google, Intel, and many more. So if you want to learn more about Project Air and what we're doing with companies like Intel and Canonical that I mentioned before, make sure to join us on the 20th. Also, in 3 weeks from now, TIBCO is having its Analytics Forum, also known as TAF. If you haven't signed up for it, there's still time. There will be great presentations from customers and partners showcasing a wide range of TIBCO-based analytical solutions across many industries.